So let's take an example where we have the arc cosine, excuse me, of negative square root of 2 over 2. And we want to find theta, where theta is between 0 and pi. And we want to get an exact value for theta. So to do that, I'm going to think about the unit circle. So remember, an inverse trig function is an angle. So another way I could state this expression here is the cosine of what angle is the negative square root of 2 over 2. If I think about the unit circle, I remember that on the unit circle, cosine is an x value. And so negative square root of 2 over 2, you might remember, is around 0.7-ish. So that's 0.5, 0.7-ish would be around right here. And with that x value in the range 0 to pi for the standard angle, that gives me a point up here. And you should recall that right there is a relative of pi over 4. So that would be the reference angle there. Oops, not pi over 2, pi over 4. So then the standard angle from here to here, which is what I'm looking for right there, would be the measure from here to there. So pi would be a full half circle, and then I back off pi over 4, so that should give me an angle of 3 pi over 4. All right, we can double check that by remembering 1 pi over 4 is here, 2 pi over 4 is here. That would be 3 pi over 4, and 4 pi over 4 would put me at pi. So the angle I want must be 3 pi over 4. We can whip out a calculator to confirm that. Let's try a similar but different problem. Suppose we have the cosine inverse of negative square root of 2 over 2, and we want to find theta, where theta is between pi and 2 pi. Again, thinking about the unit circle, very similar to the problem we just did. This again translates, an inverse function is an angle. So that means the cosine of what angle is negative square root of 2 over 2. And again, we know cosine is an x value, and that x value is around negative 0.7-ish, so that would be around here-ish. And earlier we mentioned, well, that x value right there belongs to this point here, but that x value also belongs to this point down here. And this point down here has an angle that is between pi and 2 pi. So now I want to figure out what that angle is there. Remember, the reference angle in this region here is pi over 4. So from pi, we want to add pi over 4. So then the angle I want should be 5 pi over 4. So I believe the cosine of 5 pi over 4 should be negative square root of 2 over 2. And again, there's many other angles that all lead to this point or that point right there. So if I was asked instead for an angle theta that was in the region 0 to negative pi, that means I would go around clockwise to get there. And so that angle would be negative 3 pi over 4, right? Kind of the inverse of the one I did up there. So let's check these on a calculator. So the standard position of the angle is important. We got to pay attention to that. The arc cosine at first only knows about that one right there. So let's use Desmos today. And we'll use the graphing calculator. So first, I'm just going to type in the original problem. Original problem said I had the arc cosine of the square root of 2 over 2. And it's going to give me this decimal value. Now, based on my work on the unit circle, I believe that decimal value was, oops, I wanted negative square root of 2 over 2. I believe that value was 3 pi over 4, so I can see if that's the same as that decimal value. So 3 pi over 4, and I can see, yeah, the decimal values match. So I got to know the unit circle and those special angles in order to come up with an exact answer. Calculator can easily come up with an inexact answer, an approximation, a decimal. Now, I also claimed that there was another point with an angle in a different quadrant. So our cosine only knows about quadrants 1 and 2. I needed an angle in quadrant 3, so I had to do a little unit circle symmetry to find that, and I figured out it was pi over 4. So if we check to see what happens at 5 pi over 4, we would say, okay, hey cosine, what do you know about 5 pi over 4? And it should respond with the decimal value of the negative square root of 2 over 2. And there's that negative 0.7 I was referencing. Let's just double check by entering negative square root of 2 over 2. And we should see, oops, over 2, please. There we go. And I can see I get the same number there. And again, there's many, many angles that will lead to an x value of negative square root of 2 over 2. For example, I mentioned earlier that I thought the angle of negative 3 pi over 4 would get me to that x value of the point in the third quadrant. So we can check that out. Cosine of negative 3 pi over 4, and I can see, yep, I get that same x value there. So we can use the calculator to our advantage to double check what we know about special angles. And again, by default, the arc cosine only knows about quadrants 1 and 2 here, angles between 0 and pi. So if we ever need an angle in a different quadrant, then we got to kind of play around a little with the unit circle to find that angle.